Hi, I am AMIT, Assistant Professor in Department of Mechanical Engineering of Arya College of Engineering and IT, Kukas, Jaipur. Today we will learn about the various effects of design and operating variables on the SI engines and what will the effects on the formation of the different emissions. So let's start. SI engine variables and emissions. An engine variables that affects oxygen availability during combustions would influence CO emissions. The factor which will influence flame quenching, quench layer thickness, and post-flame oxidation control. Engine out HC emissions. The burned gases, temperature, time, history, and oxygen concentration control. NO formation and emissions. Hence, the engine variables that influence burn gas temperature and oxygen concentrations would affect the NO emissions. There are various types of design variables and operating variables which affects the emission formation in the SI engines. The design variables are compression ratio, combustion chamber surface to volume ratio, ignition timing, wall overlap, air motion swirl tumble, charging stratification, and the operating variables are air fuel ratio, charge dilutions and exhaust gas recirculations, speed, load, coolant temperature, and transit engine operations like acceleration or deacceleration, etc. The effect of some variables are now we will discuss. First of all, we will discuss compression ratio. The effect of compression ratio observed when the engine compression ratio was reduced from 10:1 to 8:5, 8.5 and 7:1. By the use of high compression ratio, it will result that high burn gas temperature and lower residual gas content. This leads to higher NO emissions on volume basis. However, an engine efficiency increases with increase in compression ratio. Brake specific NO emission decreases. High compression ratio chambers results in high surface to volume ratio, a proportionately higher crevice volume, and lower exhaust gas temperatures. This is shown in this figure, that the effect of reduction of compression ratios is affecting on the different variables like on HC emissions, on NOx emissions and CO emissions as shown in this graph. Ignition timing also affects on the formation of NO and HC emissions. When ignition occurs earlier in the cycle, more heat is released because released before and around the top dead center. So with advanced ignition timing, higher peak cylinder pressures and temperature results, as has been discussed before. In combustion temperature, NO formation is increases, hence higher NO emissions are obtained as the ignition timing is advanced. As the ignition timing is retarded, more burning take place during expansion stroke, resulting in lower peak combustion pressures and a lower of mass charge is pushed into crevice volume. Also at the retarded ignition timing, exhaust gas temperature increases as the engine thermal efficiency is reduced. It is hotter, the exhaust gas with the retarded ignition timing, and the higher oxidation rate of HC emissions and CO in the exhaust system are obtained. Due to these, there is lower HC emissions are obtained with retarded ignition timing. The disadvantage of retarded ignition timing is lower engine efficiency, lower power, and a poor fuel economy. This is shown in the graph that the effect of Retarded ignition timing shows that on a different equivalence ratio, shows that at any equivalence ratio, the retarded ignition timing, the NOx emission always be decreased, and so on in the HC emission also. Air fuel ratio, the effect of air fuel ratio states that CO results due to deficiency of oxygen during combustions and is reduced as the mixture is leaned. With increased air fuel ratio, the initial concentration of hydrocarbons in the mixture is reduced and more oxygen is available for oxidations. Hydrocarbon emissions therefore decreases with increase in air fuel ratio until mixture becomes too lean. Otherwise there will be a misfire conditions and HC emissions increases very sharply. The highest burn gas temperature is obtained for mixtures that are slightly richer than stoichiometric. On the other hand, there is a little excess oxygen available under rich mixture conditions. As the mixture becomes lean, residual gas and EGR effects, the charge dilutions by the recirculations of part of the exhaust gas back to the engine is called exhaust gas recirculations. The combustion temperature decreases due to charge dilutions caused by residual burn gas or EGR. The decrease in combustion temperature nearly proportional to the heat capacity of the diluent as discussed in the previous slide. The lower combustion temperature resulting from the residual gas dilutions EGR reduce NO formations. This is shown in the graph. The effect of NO and HC emissions in normal burn and fast burn in SI engines. As we can see that with the normal burn, the HC emissions increases, with fast burn, the HC emissions will decrease, and so on the NO emissions also. This is the effect of SI engine design and operating variables on exhaust emissions, the different variables and their effects on HC emissions, CO and NOx emissions. Thank you.